video. So today we're going to look at the reverse factor formulae and how it's used to solve trigonometric equations. So before we actually look at any examples, we should first understand the concept. So let's maybe choose cos A plus cos B. Now from our factor formulae, we know that when you're adding cos A plus cos B, it's going to be 2 cos, which is 2 cos A plus B out of 2, and cos A minus B out of 2. So that's why we say cos plus cos is 2 cos, and so this is what we have now. For reverse factor formula, it means we want to come from something like this and bring it back to this. Now I want us to use this very thing as our example. Let me actually change the color such that it makes much more sense. Now if we have something like this, we want to, anytime you have something like this, 2 cos, maybe cos, like let's say something in the bracket with something in the bracket, that means that thing can in a way be brought back to an expression like cos plus cos. And now how do we do it? You come and say cos, you get the angle for the first part, you add it with the second angle, you get this, and then since this one looks like this is 2 cos, it looks like it came from something like cos plus cos, so I add and put a cos. Then how I get the second angle, I say I bring this first angle, then I subtract the second angle. So here we get cos A out of 2 plus B out of 2 plus A out of 2 minus B out of plus cos A out of 2 plus B out of 2 minus A out of 2 and again plus B out of 2. I'm opening the bracket. So here I get cos A out of 2 plus A out of 2. This becomes 2A out of 2. B out of 2 minus B out of 2, that one goes, plus cos. Here I have A out of 2 minus A out of 2, that goes. B out of 2 plus B out of 2, that's 2B out of 2. So end up having this is cos A plus cos B. So I've just literally reversed this back to that. Yeah, so that's what we've been saying. Most importantly, you should know, for example, here it is sine plus sine is equals to 2 sine cos. So meaning, if you have an expression in the form of 2 sine cos, you can change that expression to be sine plus sine by adding the angle on sine, like we've done here. Like you add the angles for the first term, then for the second term you subtract the 2 angles, and eventually you've reversed the factor formula. So now let's look at an example. Now here we have a question. This is sine cos is equals to 0.7. Now for this question, look at sine cos. You have to remember in my factor formula which expression resembled something like this. And if you remember, it's something we say cos sine plus sine is equals to 2 sine cos. But however here there is no 2, so we cannot just change this expression to look like the factor formula. So what do? We introduce a 2, so, and we cannot introduce it on one side, so we multiply through by 2 this side, 2 this side. So we'll have 2 sine this cos this is equals to 2 times this. Now after making it look like that, we can now eventually say we are going to change this to be sine. Sorry. So the first thing we've done is to multiply through by 2, as we've said. After multiplying through by 2, now it resembles like something obtained from the factor formula, and that is sine plus sine. So we bring sine plus sine, but for the first term, like for the first sine, we add this plus this. For the second sine, we get this and subtract things in the second term, then we get this. Then after we say now we have sine, we just simplify this from algebra. Don't never forget to open the bracket properly. Don't just pick x and also pick negative 12. We have to introduce a bracket, then we open this bracket. So now we come up with this expression. We take sine to the other side, so we get sine 2x plus 5 is equals to this. And then here we have sine this is equals to that. That's after putting this into our calculator. Then 2x plus 5 is equals to sine inverse of this. We put this into our calculator, we get 66.23. But remember, there are more angles. It's not just one answer. So we draw our quadrants, then all students take coffee. Then we'll see that sine is positive here and here. Then we look for those quadrants, and usually we try to go beyond 360 because we're going to subtract 5 and even multiply by 2. So that's why you say I've picked more than things beyond 360. Even if the question wants between 0 and 360, but I've gone beyond, then here I subtract through by 5. Then after here on this I divide through by 2. This is what I get. So those are the answers. Then now this is another question here. It's cos this. Cos this is equals to a quarter. So similarly here, ask yourself, what does this resemble? It resembles cos plus cos is 2 cos cos, but here there is no 2. Multiply through by 2. Sorry, multiply through by 2. We get this. After getting this, now you say cos, you add plus cos, you now get this and subtract. So you simplify this after you get this, and actually if you want to prove, you can even try and prove that when I say cos plus cos, you try to apply the factor formula here, it's going to go back to what we had in the first place. So here we have 2 cos 2x is equals to, we take this the other side, then we end up having cos 2x is equals to 1. So 2x is a cos inverse of 1. But remember, you cannot get this from the quadrants. We have to do this graph of theta against cos theta. So we draw this, then you keep going on your calculator. But by now, you should already know that the sign, that the graph of cos is symmetrical. So you just start from this and keep going. As long as all these are multiples of 90, you can get. Then now you come, this is 1, this is negative 1. So now since the question wants the cos inverse of 1, you come to 1, you look for the values at 1, the graph of 1. So we have 0, we have 360. I just didn't go further, but if you go further, you can even find 720. So you bring 2x is equals to 0, 360, even 720, then you divide through by 2, so you get 0, 180, and even 360, because I've told you even 720, but I just didn't go that far, sorry. Then now this is our exercise for us to try out. So one thing, if these ones that already have a 2, you don't actually have to multiply through by 2, since that will be a repetition. The question already has a 2, so you don't have to do it again. And these are the answers in the brackets. Try to exhaust all the potential answers, because eventually when you manipulate, even if you get something above 360, but when you divide, as you manipulate, it can go back to something below 360. So that marks the end of our chapter on reverse factor formulae. I tried to make it as short as possible.